Hello. Today I will demonstrate how to place a spacecraft in a sun-synchronous orbit. A sun-synchronous orbit is one that precesses slightly less than 1 degree per day due to the Earth's bulge. This precession is in a direction to keep the orbit plane constant relative to the Sun's direction as Earth orbits the Sun. If the orbit plane is approximately perpendicular to a vector pointing toward the Sun, the Earth satellite will always be in sunlight, regardless of where it is above Earth. To get the proper amount of precession, we need a circular orbit with inclination equal to 98 degrees and altitude equal to 700 kilometers. Since we'll be launching almost due north and need to avoid populated areas, we'll launch from northern Scotland, entering orbit about 100 kilometers northwest of our launch site. To get the timing correct, the time for entering the orbit should be either 6 or 1800 hours local time, halfway between noon and midnight. Here, we choose the latter. Start by clicking on the File tool from the menu bar and then selecting the default project option. This clears all existing orbits that you may have created. You can also do this using the Alt-D key sequence. Now, set the time to 1800 hours or 6 p.m. local time. Just keep in mind that due to your location in the time zone, this may not be exactly between solar noon and midnight. It may be necessary to make fine adjustments to the start time. You may choose any start day that you want. Next, add 10 days to the simulation duration so we can clearly see the orbit drift over time. Press the Tab key and then recalculate the orbit. Next, click on the Add Satellite button to open the Set Initial Parameters dialog box, and then choose the Parking Orbit Insertion option. Click on the Earth image approximately 100 kilometers northwest of the northern tip of Scotland. This sets the GPS coordinates for the orbit insertion. In this case, it's not a parking orbit, it's our final orbit. In the required orbit group box, set the altitude to 700 kilometers, press the Tab key, set the inclination to 98 degrees, and then press the Tab key again. Note that the required launch azimuth is 343 degrees. That's toward the northwest, but will result in an orbit that is almost a polar orbit. Now click on the Set Parameters and Recalculate Orbit button to return to the main window. Note that the ground track lines cover most of the Earth, making this a useful orbit for reconnaissance. At the bottom on the control panel, unclick the Satellite Ground Steps and Satellite Ground Lines checkboxes. Also, uncheck the Satellite Orbit Steps checkbox. Finally, check the Sun Shadows checkbox. Next, use the mouse to rotate the camera around Earth so you can see that Earth is illuminated on one side of the orbit and not the other. Note that a 5 p.m. local time would have worked better in this case, probably due to local time zones not being exactly in sync with solar time. You can change this later and try it yourself. Note also that the orbit drifts about 10 degrees during the 10-day simulation. It drifts in a direction, so the sun direction is constant relative to the orbital plane. For educational purposes, now unclick the Earth has bulge checkbox in the Earth group box and then recalculate the orbit. Rotate the camera again so you can see that the satellite no longer drifts with time. One of the benefits of this orbit is that the satellite always receives solar radiation on the solar panels, eliminating the need for batteries that store electrical energy. Thank you for watching this video. If you find it useful, please give it a like and consider subscribing to the channel. If you want to be notified when new content is added, click on the notification bell. We need your feedback, so please leave comments in the comments section. Goodbye.